Welcome to part 2 of Competency 7. In this video, we will answer questions relating to rational functions. Before we begin, let's discuss rational functions. And what do I mean by that? I mean a function that is built of a numerator and denominator. And both the numerator and denominator are functions themselves, meaning they're polynomials. Okay, so we have P of Q is the numerator, and that numerator will determine our zeros. Where does our function, our f of x, cross the x-axis? And our denominator, our q of x, cannot equal 0. And this means we need to find those restrictions, those values of x that cause everything to equal 0 in the denominator, which is not allowed. We can't divide by 0. Okay, so let's look at number 1 and number 2. All right, what is the domain of the function f of x? And as you see, we have two polynomials. But all we're interested in for the domain, we are only interested in the denominator. So if we quickly solve for x, we will get 2 over 3. This means that x cannot equal 2/3. If we plug in 2/3, then our denominator will equal 0, and that's not valid. That's one of the things, our restrictions. Okay, so that means that it can't be all real numbers along the x-axis, and it cannot be just real numbers above 2/3, and it can't be the real numbers below. So it must be everything but 2/3. It's got like a little hole there that we can't use, okay? All right, now let's look at number 2. What is the domain of the function h of x? Same situation, okay? But we can do a little more with our calculator here. So, yes, I could factor this, and I know exactly how it's going to factor. Let's put it in the calculator and talk about that. Okay, so let's do our y equals, and I already have it plugged in. Okay, so now we can graph that. And from our graph, we see that we have a negative value and a positive value. And our positive value looks like it very well could be 2, where it crosses the x-axis. Okay, so I'll factor that out for us really quick. We actually have 3x plus 4. Yes, I do believe. No, yeah, plus 4, not minus 4. And then x minus 2. And that means that we should have x equals negative 4 over 3 and x equals 2. And that is correct. But let's look at this in our table on our calculator. So second graph, and notice how I have the graph set up. Okay, so let me show you if you're not sure how to do that when you put yours in. Go second window, and I have it set where I want to look at -2 first. I want it to pop up there first. I could push 0. Let's do that. And now, how did I get that 0.333? Well, actually, what I did is I said 1 divided by 3. Okay, then I push enter, and that's how all of those 3's come up. That's equivalent. So now let's go back to second graph. Now we start at 0. Okay, and as we can see, our 2 is 0, so it does cross at 2, and that is correct. What does this really mean? It means that x cannot equal 2, and x cannot equal negative 4 over 3, which actually equals negative 1 and 1/3, okay? Well, the only option that we have is B. Well, it can't be all real numbers. That's not going to work. and it can't be between those two values that we have. And it can't just be one of them. Now, I do want to point something out. When we use our calculator, this graph that you saw, that is not the graph of our function. That is only the graph of the denominator. So if we had the numerator and the denominator graph together, that would be something completely different. Really quick, let's go back to our calculator. And there's our graph of our quadratic that is our denominator. But let's go back to our y equals. And let's go down and turn on where I have put on, I put in the actual polygon, or the polygons, polynomials that we're working with to create our h of x, our actual function. Okay, so let's graph this. All right. Oh, I need to turn it on. That makes a difference. See how didn't have it turned on. Now where it's flashing. Now let's graph it. There we go. And that will be in the pink. Notice the TI-84 does not graph well when it comes to asymptotes, okay? That is where our graph really doesn't exist. So if we go and turn on our tables, you can see where it says error in pink. That is where our 2, 0, our coordinates of 2 and 0 along the x-axis. And then let's go to our negative 1 and 1/3. There it is at the top. You see again, there's also an error. So that tells us that we're correct, where we actually see those arrows and the zeros. Okay. Number 3, what are the zeros of the function g of x? Now, if you remember, zeros are associated with the numerator, okay? And I can factor that out. I have x, if I could write that, oops, okay, that is x minus 10 and x plus 9. Well, that'll give us the correct factor, and that does give us where x crosses at 10, and the x-axis, it will be crossed at negative 9, and that gives us 8. But let's put this in the calculator and verify with a table. Okay, I have it in the calculator. Notice that it is on, whereas the y2 is not on any longer. Okay, so let's push second graph, and we can see to begin with that 10 and 0 is correct, and you go down to negative 9, and it should give us a y equal 0. Yes, our y value is 0 and negative 9. So those are two places where it crosses the axis. But let's play with this a little, and first let's turn off the first y1. Let's turn that off. That first one, because that's just our numerator. But let's look at the numerator and the denominator together. So that's why I left this one in. So I'm using it as a base. Let's delete both those out. And then we need a negative 90. See, I'm kind of just typing over it. Be careful doing this type over, though, because you can get yourself in trouble. Oh, all we need is an x, and that would be an x plus 11. So plus 11. Now, am I correct? Yes. And it's turned on. So let's graph this. Interesting. And let's zoom out so we can see the whole thing. There's a couple ways to zoom. We could try zoom stat. No. Let's get it to fit. Oh, nope. Let's go back to our regular zoom standard, and let's just use the old-fashioned zoom out and see what happens. Okay, let's push enter, enter again. Now it's starting to take shape. Okay, it really doesn't give us justice, though. Let's zoom in a little bit more. Just once more. See, we'd have to kind of move that around, but it gives you an idea of what it actually looks like. But from that, you see that our TI-84 is not a computer calculator, like Desmos or one of those other really powerful programs or powerful type calculator. It gives us enough to know what we're doing. So we have to know how to manipulate. That being said, let's go on to number 4. What are the zeros of the function h of x? Okay, again, zeros are only in our numerator. So all we need to do is look at each item in the parentheses. Okay, so the first one is x. Well, that's just x set to 0. Okay, so that's one of our zeros. It actually equals 0. Okay, and then the next one would be x equals -3. Okay, and you can tell just by looking at it that C and D are singletons. They're not going to work. A doesn't have the 0, x equals 0, so that won't work. So the option has to be B. But let's go ahead and look at our last one. Our last value of x where it actually crosses is -11/2 when we solve for x. So notice that when we're looking for zeros, these are what we call distinct zeros, and they're only those polynomials that are inside the parentheses. Notice that I did not pay any attention to that exponent of 3. Now we need to talk a little bit more about our rational function and what does it mean to have real zeros, distinct zeros, and 2 or 4 complex zeros. So as you see, we have our example here and it is graphed. However, you can't see all the zeros. In green, that will result to, when we take that quadratic, it actually results to 2 complex zeros, which have to come in pairs. So this will not be represented on our graph. However, in purple, that is the intercepts, which are the real zeros. And you'll see that that occurs at the origin and at 1 2/3, okay? Now, distinct zeros are determined by the degree inside each parentheses, not the degree of the function. So the degree of this function is 5. However, the distinct zeros, we only have 4. Okay, now let's move on and answer some questions relating to this. Number 5. Given the rational function f of x, how many distinct zeros and x-intercepts are there? Well, as we just said, you have to look inside of your parentheses. So I see 1 for the first one, which will be x equals 0, and then another one for the x squared, or 2 more. So I see 3 distinct zeros. Okay, I agree with that. So let's see, that means B says 2, so that's out. A says 3, that's why I kept it, and C says 3, and D says 1. Now, it says, how many x-intercepts are there? So what do? We just simply need to solve. So for the first one, well, that would be 0. 2x equals 0. So x equals 0. So that checks. Now let's solve the next one, and that's x squared plus 4 equals 0. So now I have x squared equals -4. You can already see what's going on here. What's about to happen? Well, we have to put both sides under the square root, and that means x is going to have to equal positive negative 2i. So that gives us, it gives us two values of x, but those are not intercepts. Those can't be because they're actually two complex numbers. So that means that our only option is C. All right, now let's look at number 6. Okay, what are the zeros of the function g of x? Well, again, if we're going to look at the zeros, we only look inside each one. Now be careful. You're looking at the degree of the items inside the parentheses. Do not look at the exponents. So that means 4, the exponent of 4 is not an option. So the first one will be x equals 9. Okay. And the next one is x equals 10 over 3. Okay. And then the next one would be a different situation. We can't factor that out, but we can use our quadratic formula. But we will get two values, however complex, and I'll show you that in a minute. Well, let's go ahead and try to start answering the actual question. Let me move up just a little. Okay. All right, so let me see here. That means I'll have 1, 2, 3, 4, 4 distinct zeros. So it isn't B because that says 7. Well, 7 is the actual degree of the whole function g of x, okay, in its entirety. And it can't be 3, okay, and I see a typo there. I'll go ahead and change that. Uh-oh, let's go back. Okay. So there is 3. There are 3. Even though that isn't the right question, let's type in the right thing. But that's not it. So it's going to be either A or C. There are 4 distinct zeros and 2 x-intercepts. Yes, I agree with A. And I'll tell you why. I'll show you why. C says there are 4 and only 1 x-intercept. Well, we just came up with 2 right here. That's a contradiction already. Now, when we go to solve for x squared plus x plus 1, and we put that into our quadratic formula, we get 1 positive negative, and then you have 1 squared minus 4 times 1 times 1 and 2 times 1. And in the end, this, oh, that's a negative right there. This actually becomes negative 1 plus minus, bring out the I and leave the square root of 3 over 2. Two complex values. So those didn't have anything to do with our choice of A in the first place. So obviously that is correct. Okay, and that's the end of our video. And once again, thank you so much for watching. If you like what you see, consider subscribing if you haven't. Could you like us and definitely share us with someone else who think these videos would do some good for them. And happy testing.